Hi everyone, today we're going to go through some important geometry questions using Desmos. And for that, we're going to review important topics first. So let's start with triangles. First are some special triangles that appear in the SAT test a lot, so you must memorize them. One of them is 3, 4, 5 right triangle. In questions, they might give you a triangle similar to it, such as 9, 12, 15. So it's better to memorize it in the form of 3x, 4x, and 5x. This is another special right triangle that you should know. 5, 12, 13 triangle. These two special right triangles are very important as well, and you can find it in your reference sheet. Now let's talk about similar triangles and after that solve some examples in this topic. Two triangles are considered similar if their corresponding angles are equal and their sides are in proportion. As you can see, we can write similarity ratio, which is the ratio of length, and also perimeter ratio, which is similar to similarity ratio, and also area ratio, which is the square of similarity ratio. As you may know, triangles are similar under three conditions. The first one is when we have two equal angles. So in that case, we know that all the angles in triangle are equal, so those triangles are similar. Another one is side angle side, when we have the ratio of two sides and angle between them, and side when we have the ratio of three sides. Also, we have a special condition for right triangles when the ratio of the hypotenuse on one side of a right angled triangle is equal to the ratio of the hypotenuse and one side of another right angled triangle. So basically, when two lengths of a right triangle is proportional, then we can say that those two triangles are similar. First question. Given the figure where AB is parallel to CD, calculate the value of x. First, notice that the two triangles are similar, right? Because we have parallel lines here, so angle B is corresponding to angle C. And also angle A is equal to angle D. So since the triangles are similar, their corresponding sides are proportional. And because of that, we can write a similarity ratio. So we're going to say x1 over 8. Because I'm going to solve it in regression, I should use x1 instead of x, and I should use tilde instead of equal sign. So x1 over 8 is, right now instead of equal, I'm going to use tilde. 4, oh no, x1 plus 2 over 4x1 minus 1. So x is equal to -1. Next question, what's the value of x given the following length? We have AE, EB, EF, and BC. Again, notice that the two triangles are similar. And this similarity comes from having equal corresponding angles. Like before, angle E and angle B corresponds to each other, angle F and angle C corresponds to each other, and because of that we have two similar triangles. So we can write similarity ratio for these two triangles. So we're going to have AE over AB is equal to EF over BC. So we're going to say EF over BC tilde AE over AB. But we don't have AB, but we have AE and EB. Yeah, so we can say x1 minus 1 plus EB x1 plus 2. So x should be 2.5. Now let's solve a question a little bit harder. Calculate the value of x. So as you can see in this question, we have so many triangles, and because of that, it may sound a little bit confusing. But it's actually very simple because we have two parallel lines here. Line EF is parallel to AH, and line EH is parallel to AB. So we can write similarity ratio 2 times for two different triangles, right? If you look at line EF and AH, we can say that triangle ECF and triangle ACH is similar because of the corresponding angles. So we can write similarity ratio. We can say that CF over CH is equal to CE over CA. Now if you look at two other parallel lines, EH and AB, we can say that triangle ECH and triangle ACB are equal. Are similar. So we can write that CH over CB is equal to CE over CA. As you can see, these two terms are equal. And because of that, we can say that CF over CH is equal to CH over CB, right? So I can say 16 minus x1 over CH, which is 16. 16 minus x plus x, which is 16. Tilde. Now I'm going to write down CH over CB. CH, 16 over CB. 16 plus 9. So that's my x. Next question. We have AH and we have BC. What is the area of square MNPQ? So we can solve this question in two different methods. Method 1, we can say that triangle AMN is similar to triangle ABC. And the reason is that MN is parallel to BC. So angle M is corresponding to angle B, and angle N is corresponding to angle C. Because of that, we can write down similarity ratio. So if we consider the length of a square as x, this little line here, let's name this AE, for example. AE is equal to 4 minus x, right? Because EH is equal to x. So we can say that 4 minus x over 4 tilde mn over bc, which is x over 8. So I find x. And we want the area of the square, so I want x squared. 64 over 9. But actually there's another way that you can solve this question. You can say that you can say that I can write an equation for the change of base over the change of height. So in that case, let's add a table here. I can say that when height is equal to 0, the base is equal to BC, which is 8. But when height is equal to 4 at the point A, the base is equal to 0, right? Because eventually at the point A, the base is 0. So if I add regression here and I add linear regression, I can have the equation here. So how can we use it? We know that the base and the height of the square is equal, right? Where height is equal to x at the point mn, at the point n, the base is equal to mn, right? So we're going to say y is equal to x. x1 equals negative 2x1 plus 8. So again, I find x. That's another way to consider. Triangles PQR and LMN are graphed in the xy plane. Triangle PQR has vertices P, Q, and R at 4 and 5, 4 and 7, and 6 and 5. So let's insert it in Desmos. P is equal to 4 and 5. So now let's make a copy. PQR Q is 4 and 7 and 6 and 5. These are points. So now we can add a polygon here. PQR. So here we have the triangle. Triangle LMN LMN okay, L is 4 and 5, M is 4 and 7 plus K, and N is 6 plus K, and 5, 6 plus K. So now we add slider K here, and it doesn't matter what is K, it's important that K is a positive constant here. And yeah, it is a positive constant. So let me just add polygon for LMN, MN. Yeah. Now we have our two triangles here. So as you can see, these two triangles are similar because line QR is parallel to line MN. And the reason is that their slope are equal. So what do you want? If the measure of Q here is t degree, what is the measure of N? So N is equal to, angle N is equal to angle R. Because of that, if this angle is T, this angle should be, and this is 90, this angle should be 90 minus T. Yeah, So C is right. 90 minus D. In the figure shown, how many times greater is the area of the larger triangle than the area of the smaller triangle? So we already know that these two triangles are similar, right? It's like previous questions. But the thing is here, we want the ratio of areas. So it's important to know that we can find a similarity ratio, but the ratio of areas is just a square of a similarity ratio. So I can say, let's find similarity ratio first. X plus 3 over 2x1 plus 3 tilde x1 over 2x minus 1. So we found x, but we want a similarity ratio. So let's find x over 2x1 minus 1. So this is our similarity ratio. But we know that the ratio of areas is square of similarity ratio. So this is the ratio of areas. But we want to know how many times greater is the area of the larger triangle than the area of the small triangle. So the larger triangle over the area of larger triangle over the area of smaller triangle is 16 over 9. So guys, now that we solved so many questions from triangles, let's solve some questions from the topic of circles. As it is mentioned in your reference sheet, the number of degrees of arc in a circle is 360, and the number of radians of arc in a circle is 2 pi. Another important thing that you should know is about the inscribed angle. The inscribed angle subtended by an arc is half the central angle subtended by the same arc. So for example, take a look at this picture. As you can see, if an inscribed angle subtends a semicircle, then the angle is 90 degrees. So what does it mean in questions? It means that if you have a triangle in a circle, that one of the length is equal to the diameter of the circle, it means that that triangle is a right triangle because the inscribed angle is 90 degrees. Also, it's good to know that the inscribed angles subtended by the same arc are equal. For example, in this picture, these three angles subtended by the same arc, which is AB. So these three angles are equal. Now let's talk about one of the most important subjects of geometry in SAT math, tangent line. A tangent line is a line that touches a circle at exactly one point. Now let's review some key points of tangent lines. First of all, you should know that the distance from the center of the circle to the tangent line is equal to the radius. Second, the angle formed between the radius and the tangent line at the point of contact is always 90 degrees. So it is a right angle. Or let me say it in a simpler way. The tangent is perpendicular to the radius at the point of contact. So why is this useful? First of all, we can use it to find missing angle. So for example, in this example, we know that O is 60. And also AB is the tangent line. So AB is perpendicular to AO, which is the radius. So ABO is a right triangle. We know that we have O, we have A, so the angle B is 180 minus 90 plus 60. Another application of this property is to find the length of the missing side. For example, take a look at this picture. AB is our tangent line, and we know that it's perpendicular to OC, which is the radius of our circle. So the triangle OCB is a right triangle. So we went over it. We know that this triangle is one of our special triangles, right? We have 5, we have 13, so x should be 12. But even if we didn't know that, we can use Pythagorean theorem to find x. Another thing that you should know is that from a point outside the circle, you can draw two tangent lines. And these two tangent lines are equal. And it's very easy to prove, right? You just need to prove that these two triangles here, COA and COB, are congruent. For that, we know that these two triangles, first of all, these two triangles are right triangles. And also AO is equal to OB because both of them are equal to the radius of the circle. Also, they share the same hypotenuse, right? So as a result, we can say that these two triangles are congruent, so their corresponding lengths should be equal. That's the reason CA is equal to CB. The line segment CD is the common external tangent to the two circles shown in the figure below. Given the information, find the distance between the centers of two circles. So I can solve this question in two different ways. I can say that since CD is tangent to these two circles, angle D and angle C are 90 degrees. And because of that, if I draw a line from the point B parallel to line CD, I can have a rectangle and a right triangle. So in that case, my rectangle has the lengths of 55 and 20, and the right triangle would be, the length of right triangle would be 5 and 55. So in that case, I can find AB with Pythagorean theorem. So let's say 5 squared plus 55 squared is equal to 3050. So AB would be 55.2, roughly is equal to 55.2. I can solve this question using another method. I can insert the points I have on Desmos. So I can say D, for example, is equal to 0 and 0. Let's make a copy for 4 points. So if D is 0 and 0, C should be, let me first label it, D, C. C should be 55 and 0. In that case, A should be 0 and negative 25. And D and B should be 55 and negative 20. Yeah. So these are my points. Now I can use the function of polygon here. Polygon DCBA. The order is very important for a polygon function. For example, if I say DCAB, you see something like that happen. DCBA. So now I can use the function of distance to find the distance between A and B. So I can say distance of A and B. As you can see, again, I find the distance between A and B, which is roughly equal to 55.2. Find the perimeter of the triangle based on the known length of the tangent segments. So this is a very simple question. We don't need to use Desmos to solve it. It's just that I want to solve it because it's so important to know this idea that if I have a point outside a circle and I draw two tangent lines from that point, in that case, those two tangent lines are equal. So it means that this line here is equal to 3, this one here is equal to 4, and this one here is equal to 7. So the perimeter is equal to 14 multiplied by 2, which is 28. A circle has center G and points M and N lie on the circle. Line segments MH and NH are tangent to the circle. We have the radius of the circle and the perimeter of GMHN. What is the distance between points G and H? So let's draw it on Desmos. For having a circle in this Desmos, we can write down R equals to some number. So as you can see, I have a circle with the radius of 5. So just because I want the schematic of the problem, I don't care about the numbers here. So now I have a circle and points M and N lie on the circle, okay? So I can say M is equal to I can drag these points wherever I want. So let's say N is here and M here. It doesn't matter. So now I have a point outside of the circle. And I know that G is the center of circle. So center of this circle is 0 and 0. So now if I use polygon for G, M, H, and N, yeah. The figure is something like that. So I know that the perimeter is 3,856. But I know that mg and ng is equal to the radius. So let's find hm and hn. So the perimeter minus 2r, r is 168. So this is the sum of hm and hn. And we know that these two are equal, right? So hm is equal to hn is equal to 1760. So the question wants the distance between G and H. So this is what we want, right? But we know that n is 90 degrees, right? So triangle H and G is a right triangle. So I can find HG using Pythagorean theorem. So in that case, I can say NH, which is 1760 squared plus NG, which is the radius, squared. So no, we have H before. Let's say this is equal to Q. So now I want the square root of Q. So as you can see, this is the right answer. The distance between G and H based on the Pythagorean theorem is 1768. A circle is inscribed within a right triangle. We have side A, B, and C. Find the area of the inscribed circle. So because we have a right triangle, we can use Pythagorean theorem. So we can say a squared plus b squared is equal to c squared. And because I want to use regression, I'm using x1 instead of x. So 10x plus 3 squared plus 11x plus 13 squared is equal to 16x minus 3 squared. So there's a problem. X is negative, so I need to add this condition. That x should be positive. So now I have the right answer. You see, regression only gives us one answer, even when we have so many answers. So sometimes the answer that regression is given to us is not the answer that we want. So we need to add a condition so that we find the right answer for ourselves. So we find x. Now let's find the length of a triangle. So 10x plus 3, 11x plus 13, and 16x minus 3. So the length of the triangle is 133, 156, and 205. Find the area of the inscribed circle. So I can say that this line here is equal to r. This one here is equal to r again, and this one here is equal to 133 minus r. So this line here is also equal to 133 minus r. So this line here is equal to 156 minus r. So this line is also equal to 156 minus r. So the sum of these two is equal to 205. So r is equal to 42. And the area is pi multiplied by 42 squared. This is the area of the circle. In geometry problems related to circle sectors, you are usually asked to find either the area of the sector or the arc length. There is a very simple idea that helps you solve these questions easily. The key is to use ratios. The ratio of the sector's angle to the full circle is the same as the ratio of the sector's area to the area of the whole circle, and also the same as the ratio of the arc length to the circumference of the circle. If the angle is given in degrees, we compare it to 360 degrees. If it is given in radians, we compare it to 2 pi. Once you understand this relationship, solving sector problems becomes very straightforward. The circle above with center A has an area of 21. BC is tangent to the circle with center A at point B. If AC is equal to AB, then what is the area of this shaded region? So BC is tangent to the circle, so B is a right angle. And because of that, triangle ABC is a right triangle. Also, we know that based on the question, AB is half of AC. So we reviewed it at the part of special triangles. It means that angle C is equal to 30 degrees, and in that case, angle A is equal to 60 degrees. So it means that the angle of this sector, this shaded sector, is equal to 360 minus 60, which is 300. So as we discussed, the ratio of arc angle to the whole angle, which is 360, is equal to the ratio of the area of the circle sector to the circle area, right? So we can say that 300 over 360, this is the ratio, is equal to the area of the circle sector, which we don't have. So I'm going to name that A, over the area of the circle. The circle above its center has an area of 21. Okay, so the area is 21. So it means that the area of the sector is 17.5. The sector of a circle shown has center at O. The radius of the circular sector is 10 and the area of the sector is 75. What is the length of the arc XYZ? Whenever we see a question from the sector of a circle, we should find the ratio. So in this question, we know the area of the sector, which is 75, over the area of the whole circle, which is 10 squared multiplied by pi. Pi multiplied by 10 squared. So this is equal to, what we want is the length of the arc. So let's say L over the perimeter of the circle, which is 2r pi. Pi multiplied by 20. So L is equal to 50. The sector of a circle shown has center at O. The radius of the circle has length 5. The arc X set Y has length 7. To the nearest length, what is the shaded area of the sector? Okay, we want the shaded area. What do we have to find the ratio? We know the radius of the circle and we know the length. So we can say 7, the length, the arc length, 7 over the perimeter of the circle, which is 2 pi r. What was r? I forgot. 5. So 10 pi. It's equal to the area we want, the area of the sector, over the area of the circle, which is 25 pi. So the area of the shaded region is equal to 17.5. A rectangle is inscribed in a circle such that each vertex of the rectangle lies on the circumference of the circle. The diagonal of the rectangle is twice the length of the shortest side of the rectangle. We have the area of the rectangle, what is the length in units of the diameter of the circle. So when we have a rectangle in a circle, the diagonal of the rectangles is always equal to the diameter of the circle. And it's actually very easy to prove. Try to see if you can prove it yourself. So right now, let me just draw a schematic of the question, just that you can understand what I'm talking about. And after that, I try to solve this question. So, okay, we know that the area of the rectangle is equal to 1089 root 3. So, x multiplied by y is equal to this cube over 3. So I consider this x and I consider this length here as y. And I also know that the diagonal of the rectangle is twice the length of the shortest side of the rectangle. So it means that if I write down the Pythagorean theorem for this triangle here, I can say x squared plus y squared is equal to, and we know that AC is equal to twice the x, twice the CB. So this is 4x squared. Right? So let me clear that first. As you can see, I have two answers, but I know that x is a length of the rectangle, and because of that, it cannot be negative. So our answer is 33. 33 is x, the width of the triangle. So what is the diameter of the circle? The diameter of the circle is twice the width, so is 2x. The diameter is 66. Now let's go to the next topic. So for prisms and cylinders, the value is area of base multiplied by height. Also, you can check out reference sheets. There is some formula there that it can be helpful during the test. You should know the difference between lateral area and surface area. Lateral area is the area of all sides faces, excluding the bases. So, for example, in this cylinder, lateral area is the curved surface area. Surface area is the total area of all faces, including the bases. So we can say that surface area is just lateral area plus area of bases. For example, in this cylinder, total surface area is just curved surface area plus two circular bases. As you can see, when you unwrap the lateral surface of a cylinder, it becomes a rectangle. The height of the rectangle is the same as the height of the cylinder, which is h. The length of the rectangle is equal to the circumference of the circular base, which is 2 pi r. So the lateral surface of a cylinder can be represented as a rectangle with height h and width of 2 pi r. Therefore, the lateral surface area of a cylinder is 2 pi r multiplied by h. This is why we use the formula 2 pi r h for the lateral area of a cylinder. For example, take a look at this cylinder. We want to find the lateral area and surface area. For lateral area, as we discussed, we have 2 pi rh. And we have r, which is 3 inches, and h, which is 7 inches. So we can calculate lateral area. As you can see, the lateral area is roughly equal to 131.88. And if we want to calculate surface area, we just need to add lateral area to area of two bases. So we have two circular bases, and we know that the area of a circle is pi r squared. So we can find b. And we need to double it because we have two circular bases. This is how we calculate surface area, which is equal to 188.4. Now let's calculate lateral surface area of triangular prism. As you can see in this prism, we have a triangle base with lengths of A, B, and C. So for calculating the lateral surface, we need to calculate the area of these three rectangles. The height of this three rectangle is equal to h, but the width is different. For one of them is A, for another one is B, and for the third rectangle, the width is C. So for calculating area, we have AH plus BH plus CH. Now let's see how to calculate the surface area of a cone. As you can see, a cone has a circular base, so base area is equal to pi r squared. And the lateral surface area is equal to pi rs. R is radius and S is slant height. So first of all, let's see what is slant height. The slant height is the length of a segment along the outside of the cone or pyramid from the vertex to the base. So surface area is equal to pi r squared plus pi rs. So how did we find pi rs? It's because when you unwrap the cone, you will have a sector of a circle. So for finding the area of a sector of a circle, we need to use this formula, half of radius multiplied by arc length. So here, if we plug the cone's values r and l, we will have a half of l multiplied by 2 pi r, which is pi rl or s, it doesn't matter. So this is exactly why the formula works. You don't need to remember these formulas, you just need to understand how to calculate it, how to find it. Let's solve this question. The height and the slant height of a cone are 21 cm and 28 cm respectively. Find the volume of the cone. So we know that the volume of the cone is 1/3 of pi r squared h. So now we have slant height and height of cone. So with Pythagorean theorem, we can find r. After that, we use the formula of volume of the cone to find the volume. It's very helpful to look at this table and try to figure out how to calculate a lateral surface area. So you can do it as a practice to understand how it works. A rectangle has an area of 155 square inches. The length of the rectangle is 4 inches less than 5 times of the width of the rectangle. So it means the length is equal to 7 times of width. 4 inches less than 7 times. Okay, minus 4. This is the length. So we know that the area of the rectangle is x multiplied by length, which is 7x. I'm using regression, so I'm using x1 instead of x, minus 4. So this is equal to 155. So what is the width? The width is equal to 5. Two identical rectangular prisms each have a height of 90 centimeters. The base of each prism is a square, and the surface area of each prism is k. If the prisms are glued together along a square base, the resultant prism has a surface area of 92/47k. What is the side length in centimeter of each square base? So let's consider side length of a square base as x. Each prism has two bases, top base and bottom base. So we're gonna have 2x squared plus, and we have four faces with height of 90 and length of x. So 4 multiplied by. So this is equal to k. Now if we have two prisms glued together along a square base, we know that the bottom base of this prism and the top base of another prism, they become hidden. So we're going to have two square bases and 8 faces with the height of 90 and length of x. x1. So this is equal to, based on the question, this is equal to 92 over 47k. So to solve this, let's use this term instead of k. And we need to add a condition that x1 is bigger than, for example, 1. So yeah, the silence is equal to 8. Today we solved so many geometry questions using Desmos, and I hope that this video is helpful for you. If it is, please leave a comment, like, and subscribe to my channel. Thank you very much for watching this video. I hope I see you in the next one.